All right, we're going to start off today by talking about trigonometry. You might have heard trigonometry before. You might have heard the word trig. So this is what we're actually going to be talking about today, which is the study of triangle measurement. So that's going to be angles and sides. So these are going to be the three that we talk about today. So sine, cosine, and tangent. The sine function, that is actually a ratio, and it's of the leg opposite the angle to the hypotenuse. So if I'm looking at angle A, so the sine of angle A, zoom out a little bit here. The sine of angle A, well, let's look at A. I want the leg opposite from that, so the leg opposite of angle A is little a, over the hypotenuse, the longest leg across from that right angle would be C. So it would be A divided by C. That's that ratio. If I look at angle B now, the leg opposite of angle B is that lowercase b, and then my hypotenuse still stays the same and is C. So that's the ratio that you're going to see for sine when we use that. Cosine, I'm going to look at my angle and I'm going to pick the leg that is adjacent to it and the hypotenuse. So if I look at angle A, I have two angles that are adjacent. Two legs that are adjacent to angle A, that's B and C. However, C is also the hypotenuse. So that's what we're going to refer to it as. It can be adjacent, but we're going to talk about it being just the hypotenuse this time. So for angle A, the adjacent leg would be B, hypotenuse is C. Now let's focus on angle B. So we are looking at the adjacent leg to that one. Once again, C is also adjacent, but that's the hypotenuse. So we're going to look at side A over C, my hypotenuse. And the reason why we're not talking about angle C at all is because we're only looking at acute angles here when we talk about right triangle trigonometry. All right, last one is tangent. So tangent, that is opposite over adjacent. If I look at angle A, the opposite leg would be side A. Adjacent then would be side B. Now if I look at angle B down here, we're talking about the tangent of B. Opposite leg would be B, and then adjacent leg would be A. So you're going to be using these ratios to find missing side lengths, missing angle measurements, and this is going to be the basic way for how you can remember it. It's called SOHCAHTOA. SOHCAHTOA. Now each one of these letters stands for something. So when you see so, that's the sine function, and it's here to help us remember that that is the opposite side over the hypotenuse. Ca, you're dealing with cosine, and that's to help us remember that that's the adjacent side over the hypotenuse. And then lastly, toa is tangent. So that's to remind us that is the opposite side over the adjacent side. So I want you to use SOHCAHTOA a lot. I still use it today to help me remember how I'm going to set up these ratios. So let's start with number 1. So the sine of A. So instead of using the names of the sides, I have measurements for them. So we're going to use those measurements to set up these ratios. So sine A. So sine, we said, is opposite over hypotenuse. So the leg opposite of A is 5. My hypotenuse then is 13. And we always want to write these as fully reduced as possible. I'm not going to have that issue with these, but as we go down to numbers 2 and 3, you are going to have to reduce your fractions. Cosine of A, that is your adjacent over hypotenuse. So that would be 12 over 13. And then the tangent of A, that is your opposite over adjacent. So that would be 5 over 12. Sine of C. Well, now we're going to focus on C and use that one to find our ratios. So sine is opposite over hypotenuse. Opposite would be 12. Hypotenuse is 13. The cosine of C, that is your adjacent side, which is 5, over your hypotenuse, which is 13. And then lastly, your tangent of C is your opposite, which is 12, over your adjacent of 5. I'm going to start you off with number 2, and then I want you to give it a shot. So for number 2, in order to do these, you need to know all 3 side lengths. We're just setting up the basic ratio. So if I were to use Pythagorean theorem, I would see that x is then equal to 15 over here. That is your hypotenuse. So I'll start off the first few, and then I want you to go through and try the rest on your own. So the sine of W, so sine is opposite over hypotenuse. That would be 12 over 15. If I reduce that, they're both divisible by 3. So I would get 4 over 5. You always want to reduce these fractions as much as possible. Cosine of W. Cosine is your adjacent side of 9 over your hypotenuse of 15. Reducing that, both divisible by 3, I get 3 over 5. And then the tangent of W, that is your opposite side over your adjacent. So that would be 12 over 9. And then if I reduce that fully, I get 4 over 3. What I want you to do now is to go through, give these a shot on your own. You're going to have to find that missing side then for number 3 as well, but just set up the ratios and reduce them. Here we go. Here should be your answers for numbers 2 and 3. So when you go through, you are finding those ratios, but then you always have to reduce them as far down as they can go. And we're going to be using these then on the next page to help us find missing side lengths. So you're going to be using these ratios then and incorporating the angle measurements, not just their name. All right, so now we are going to use those trig ratios to find missing side lengths of my triangles. So I'm going to write up SOHCAHTOA on the top of my paper just to help me, and I can go back and reference. This is going to be really helpful for you as you go through and try to find these lengths. So let's start here. I have this angle measurement, and I'm going to use the fact that I know what this measurement is to help me find what my value of x is. So from this angle, let's see what I have. I have an opposite side, and the 19 gives me my hypotenuse. So from here, I'm going to look to see how can I set this up. So which trig ratio gives me opposite and hypotenuse? Well, if I look up top here, I see opposite and hypotenuse with sine, so that is what I will use. So I'm going to say the sine of, instead of the name of the angle, I'm going to use the measurement, which is 28 degrees. This actually simplifies into a number, which we'll use our calculators to find. So the sine of that angle equals my opposite side is x over my hypotenuse, which is 19. My goal here is to go through and solve for x. So I'm going to multiply top and bottom by 19. So in order to find x, I'm just going to go through multiplying 19 times the sine of 28. So I'm going to pull out my calculator. So I'll type in 19 times. So if you were to look on your calculator, you actually have buttons that have the trig ratios on them. Even if you have a scientific calculator, you'll still see them. I see sine, cosine, and tangent right here. So I'm going to type in the sine, and my angle measurement was 28. So I'll type that in, close the parentheses, and hit enter. And I get 8.9 is my value for x. All right, let's try another one. So here I'm given this angle measurement for number 5. I'm going to go through. I have an opposite. This is my hypotenuse because I see it's across from the right angle, so I will consider this one to be my adjacent side. So which trig function uses opposite and adjacent? It looks to be tangent, O and A for opposite and adjacent. So the tangent, instead of naming the angle, I will use the measurement. 41 equals my opposite side over my adjacent side. I will multiply both sides by 32 to solve for x. So in order to find x, I'm taking 32 times the tangent of 41. I'm going to use the scientific calculator this time. So you're taking 32 times. Make sure you're clicking on the tangent button of 41. I'm going to hit enter. That gives me 27.8. Now, if you are going through and you're using your calculator and you're not getting these numbers even when you plug it in correctly, I want you to double check that this is in degree mode. If it's in radian mode, it'll say RAD, which stands for radian. Now, in order to fix this, you're going to look at this button that says DRG, that stands for degree. So I'm going to click that and make sure that degree is highlighted and not radian mode. Okay, so once you've highlighted degree, hit enter. Check it again. There it is. All right, let's do 6 and 7 together, and then I will pause and let you try 8, 9, 10, and 11. 6 and 7. I look here. From this angle, I have an adjacent and a hypotenuse. Adjacent and hypotenuse, which trig function uses adjacent and hypotenuse? That would be cosine. So the cosine of 21 equals my adjacent, which is x, over hypotenuse is 26. Multiply both sides by 26. So my value for x equals 26 times the cosine of 21. Let's calculate it, figure it out. So 26 times the cosine of 21, 24.3. All right, last one that we'll do together for right now. I'm going to use 55. That's the angle that's given to me. I have opposite and adjacent. So which trig function uses opposite and adjacent? Well, it's the one that we just used for number 5. That would be tangent. So the tangent of 55 degrees equals my opposite leg is x over my adjacent is 8. So I'll multiply both sides by 8 to solve for x. So I'm going to take 8 times the tangent of 55. 11.4 is equal to x. All right, pause this and try numbers 8 through 11. Okay. Let's go through these now. Hopefully you have these written down in your paper. So for number 8, I have 33. That gives me an opposite and hypotenuse. So going through, that gives me sine. So the sine of 33 equals 15 over x. So this one's a little bit tougher because you have x in your denominator. Multiply both sides by x. It'll cancel it out over here. So I have x times the sine of 33 equals 15. And then to get x by itself, I will divide everything by the sine of 33. These will cancel. So what is 15 divided by the sine of 33? Oops. I get 27.5 is my value for x. All right. I start here with number 9. Let's go through. I have adjacent and hypotenuse, that is cosine. Once again, multiply top and bottom by x. I have x times the cosine of 43 equals 36. Divide both sides by the cosine of 43. Cancels it out over here on the left. 36 divided by cosine of 43 gives me 49.2. For number 10, let's see what we have. We're given this angle here. We want to go opposite and adjacent. So which one uses opposite and adjacent? That would be the tangent of 72 degrees equals 25 over x. Multiply both top and bottom by x. Cancels out over here. So I have x times the tangent of 72 equals 25. Now I'll divide both sides by the tangent of 72. So those cancel. 25 divided by the tangent of 72. 8.1. And then lastly, number 11 here for the basic type of problem. I have adjacent and hypotenuse. That would be cosine. So the cosine of 64 equals my adjacent over hypotenuse. So I'll multiply both top and bottom by 11. So x equals 11 times the cosine of 64, and I will just go through, multiply that one out. 11 times cosine of 64. Get 4.8. So you have 2 word problems on the bottom, and I've already gone ahead and just sketched these out a little bit. So for number 12, Jake leaned a 12-foot ladder against his house if the angle formed by the ladder and the ground is 68 degrees. How far from the base of the house did he place the ladder? So I'm looking for the distance away from the house that ladder is planted. So if I look here, this is my adjacent, and this is my hypotenuse. So that would be cosine. So the cosine of 68 equals x over 12. Multiply both top and bottom by 12. So I'm going to take 12 times the cosine of 68. And that gives me 4.5, and I'm going to use that correct unit of feet away from the house. All right, last one. 13, a ramp is used to load suitcases on an airplane. So here's my little airplane here. Here's my ramp. If the cargo door is 7 feet from the ground, so I know from that door to the ground is 7 feet, and the angle from the ground and the ramp is 25 degrees, how long is the ramp? So from the angle that I'm given, I have an opposite and a hypotenuse. So that would be sine. So the sine of 25 degrees equals my opposite over hypotenuse. So I'm seeing x in my denominator again, have to get that out. So x times the sine of 25 equals 7. Divide both sides by the sine of 25. So I'm going to take 7 divided by the sine of 25. I get 16.6 feet is the length of that ramp. And we are done.